Looking at the equation, you make hydrogen. That's a gas. Therefore, you can use the mass, pressure, or volume strategies, depending on if you have the equipment. Also looking at the equation, you have an acid on the left side, but no acid on the right side. That means you can track pH changes over time. And finally, let's count ions. This is a solid, so no ions. But HCl, that's aqueous. 2 HCl's will fall apart and give me 4 ions, 2 H pluses and 2 Cl1 minuses. On the right side of the equation, that's a gas, so no ions, but MgCl2, that's aqueous as well. So that falls apart and gives me 3 ions, 1 Mg2 plus and 2 Cl1 minuses. So I have 4 ions on the left and 3 on the right. That means I will have a conductivity change. So I could track this change using a voltmeter. Example 2 gives you some experimental data and asks you to calculate the rate. If you mix sulfuric acid and magnesium, you'll get a single displacement reaction making hydrogen gas. We mix them in a 2.5 liter container. Over a period of 1 minute, the pressure inside the container increases by 25.8 kPa at 25 degrees Celsius. So this experiment is employing method number 2, tracking pressure using a pressure gauge. We want to calculate the rate of hydrogen gas production in moles per second. Because hydrogen is a gas, I'm going to use the ideal gas law to figure out how many moles I have. The only thing that I'm missing here is little n. The pressure change is 25.8. My volume is 2.5 liters. R is 8.314. And my temperature in Kelvin is 298. To calculate the rate, I will take my change in moles divided by my change in time. Now I created that many moles in 1 minute, or 60 seconds. That gives me a rate of 4.3 times 10 to the minus 4 moles of hydrogen per second. Now, as a follow-up question, I could ask you, how fast did the sulfuric acid disappear? You would take your rate in moles of hydrogen per second and times by mole ratio to solve that problem.